Here are the classes we have created so far: data source, spreadsheet, and chart. We want the data source to talk to these classes, but without being tightly coupled to them. So we should have these classes implement a common interface and have the data source talk to that interface. So we introduce a new interface called observer and have the data source talk to this observer interface. This follows the open-close principle because we can extend our application by adding new classes. Let's say tomorrow we want to introduce a new type of object, like an image that gets auto-generated based on the values in the data source. We can simply add a new class that implements the observer interface. The data source doesn't care. It just talks to the observer interface. So in the data source, we need to maintain a list of observer objects. That is why we have the composition relationship here. Now, when we set the value in this data source, we need to notify these observers. How can we do that? That is very easy. We can use the polymorphism principle one more time. So we introduce a new method in this interface called update. Then in the set method, we simply iterate over the list of observers and call the update method. So here we have polymorphic behavior. Depending on the type of observers we have, a different update method will be called. Each concrete implementation, like the spreadsheet or chart, will figure out how to update themselves. Now, to bring all this together, we need to introduce 3 new methods in this class. Add observer for registering an observer. So we simply call this method, and the data source will add this observer object to its list of observers. We need a similar method called remove observer. This is useful in situations where, let's say, the user deletes a spreadsheet. So we don't want that spreadsheet to be notified about the changes in the data source. So with these 2 methods, we can add and remove observers dynamically at runtime. And this makes this class very flexible. Now, the last method that we need here is notify observers. In this method, we simply iterate over the list of observers. So for each observer, we're going to call observer.update. And this is where we have polymorphic behavior. This observer object will take on many different forms depending on its type at runtime. Now, you might be curious why I added this method here. Why don't we implement this loop inside the setValue method? Well, this is a very simple class with a single field. But what if we had multiple fields and these fields could be updated independently? We don't want to repeat this logic in multiple places. So we have a single place for notifying all the observers. These are the objects that are interested to know about the changes in this data source. So in our set method, we simply call the notify observers method. And this is what we call the observer pattern. Here's the structure of this pattern as outlined in the Gang of 4 book. So we have this abstract class called subject, and this is where we have these methods attach and detach. These are like add and remove observer. We also have the notify method. So all this logic for maintaining the list of observers and notifying them are implemented in a single place in an abstract class, so we can inherit all that behavior in concrete subjects. A concrete subject is like our data source class, okay? Now we have this observer interface exactly like what you saw before with a single update method, and we can have many different implementations of this interface. For example, we can have a chart, a spreadsheet, and an image, and so on. So this is the observer pattern, also known as the publish subscribe pattern. Because this subject class plays the role of a publisher, it publishes changes in its state, and these observers are a subscriber to those events. So now that you know how the observer pattern works, let's go ahead and implement it in code.